show and have the chance to win a brand new car. It sits behind one of these 3 doors, but the other 2 have a sad little goat behind them. You make your choice, and the host decides to reveal where one of the goats is. He then offers you a chance to change your door. Do you do it? Does changing your choice even make a difference? The short answer is yes. Even though it seems counterintuitive, changing your door choice actually doubles your odds of winning the car. But how is that possible? This is the Monty Hall problem. At the start, most people correctly assume that you have a 1 in 3 chance of choosing the correct door, but it would be incorrect to assume that when one door is removed, each door now holds a 50-50 chance of having the car. Let's use a deck of cards to understand why. Pick a card from this deck without looking. This card has a 1 in 52 chance of being the ace of spades, but now I'm going to flip over all the other cards except one, none of which are the ace of spades. Of the 2 cards left, which one seems more likely to be the ace of spades? The one you chose randomly out of a deck of 52, or the one I purposefully and suspiciously left turned down? It turns out your card remains at a chance of 1 in 52, where my card now has a 51 out of 52 probability of being the ace of spades. The same principle is true with the 3 doors. You see, when I removed the door, I did so with motive, knowing there was a goat behind it. The only 2 scenarios that exist are A, you chose the correct door and I'm arbitrarily picking one of the wrong choices to show you, in which case staying will make you win, or B, you picked the wrong door and I show you the other incorrect answer, in which case switching will make you win. Scenario A will always happen when you choose the winning door, and B will always happen when you pick a losing door. Therefore, A will happen 1/3 of the time, and B will happen 2/3 of the time. As such, switching your door wins 2 out of 3 times. This paradox has perplexed many people, including scientists and mathematicians to this day, because our gut tells us that switching will have no consequence. But when using formal calculations or computer simulators, the results don't lie. Switching your door increases the probability of winning. Let's see it one more time using a chart. Here are all the possible scenarios. The car is behind door 1, 2, or 3, and you have the choice of each 3 doors. This means there are 9 possible outcomes. Let's tally them up quickly. If it's behind door 1 and you chose door 1, you should stay, but if you chose door 2 or 3, you should switch. If it's behind door 2 and you chose door 2, you should stay, but the other 2 you should switch. Add it all up, and you should switch 6 out of 9 times. So, do you still trust your gut feeling?